Okay, today we'll see the data types. In the last class we have seen the same data types only. Okay, data types. Data types are the used in the Verilog HDL in order to which will support the which will support what the conventions. Okay, what are the some types of data types we'll be using? Okay, around 9 data types are there. One is what the value set. Another one is the nets. Another one is what the registers and the vectors and arrays, and also one more is that integer real and type of time data types. And also here we have the one more is that memories, parameters, and also memories and also strings. Okay, strings. These are the how many are there? 8, 9 are there. Okay, 9 data types are there. How many? 9 data types. In the last class we have seen the value set, nets, registers, and also vectors also. Today we will discuss we stopped there only vectors. Value set are nothing but what is which we have to be give some values. Okay, in which will support the 4 types of values that are there. One is what the 0, 1, x, z. Okay, 0 is nothing but what which will give the logic false conditions. Okay, which will give the true logic. Okay, true conditions. X is nothing but the logic can have the 0 or 1. It's like what the don't care conditions in the last class we have seen. Z is nothing but the impedance. Okay, impedance can also have the both values as the 0 or 1. People get confused. Okay, in the logic value set. Okay, around the 4 types of value sets are there. One is 0, 1, x and z. These to be written. Okay, when we go with the simulation, waveform simulation, there will get the, if it is my logic is 0, in the waveform simulation time it will give the same as the 0th only. If my value is 1, then definitely my simulation waveform will get the higher portion. Then my value is x, either it can be 0 or 1, or whether it can be 0 or 1, x is the thing, don't care, or else it can have the both. Okay, both like this. It will give the some x type. Okay, x types. Okay, this will give the like this. Okay, even the impedance also shows the same as the upper version only. Upper version it will also show it can also have the both values as the 0 or 1. In the simulation time we will be okay. In the simulation time we will have these type of conditions, and also we have also we have in the value set also we have the strengths. These value sets will work on based on the strengths. There are around 8 types of strengths are there. 8 strengths are there. There are 8 strengths. Value sets are how many? 4. 8 strengths are there. 8 strengths are nothing but this strength is nothing but whenever we have the 2 inputs 0, 0. If it is a 0, 0 inputs, then definitely what will be my strength here? If my inputs are nothing but both are 1, 1, then it has to consider the which one. Okay, this based on these combinations of the value set we have around 8 types of the 8 different types of for the strengths also. Which are those? Supply. If I am giving the supply, in my digital system is having the supply also, input as the supply also. If it is having if it is a driving type, okay, this is what the driving type, and also we have its degree is what the strongest one, it's what the strength of the level. This level is this is what the level, this is the type, what the type of the strength is there, and also driving type, this is what the degree or driving type. Okay, driving type, this is what the supply is nothing but it has the driving type, this is what the driving type. Okay, and also it's what the strongest one, this is what the strongest one, degree is what the strongest one. If my input is what the strong, okay, that's nothing but the strongest, strong is there, supply is there, strong is there, then this is also what the driving type, this is what the also driving type, and also degree is what here the this is also strongest one only, it's increasing somewhat, it's compared to what the strongest one, it has the less energy, less degree. Okay, less degree. Then the input supply is what the type of pull it antigore, that is also having the driving type, this is also what the driving type only, this is what the type of driving type only, this is what the compared to the strongest one, it's also less energy, it has also less degree. And also large is there, large is there, which will be used only when we meet the two types of logic conditions. We'll see that one. Okay, logic large is there, this is what the, this is also what the logic is, large is what the storage type, this is what the storage type, storage type, this is also strongest one, less is there energy. And also weak, weak is one more strength level, this is what the driving type, this is also driving type. And also medium, small, medium, and also smaller one is also, this is also driving type. And also high Z is nothing but the impedance, this is what the high impedance, this is what the high Z is nothing but the high impedance, high impedance. The only the high impedance is only one the which is having the weakest one. Weak andre this, there is no inputs, this one ನೀನು ಯಾವುದೇ ರೀತಿ inputs ಕೊಟ್ಟರು ಕಾಂಬಿನೇಷನ್ ಆಫ್ ದಟ್ ಡಿಗ್ರಿ ಲೆವೆಲ್ ಇಸ್ ವಾಟ್ ದ ವೀಕ್, ಅಂದ್ರೆ ಅದ್ರದ್ದು ಅದು ಅಷ್ಟು ಎನರ್ಜಿ ಇರಲ್ಲ ಅದಕ್ಕೆ, ಅದು ಅಷ್ಟು ದಟ್ ಒನ್ ವಿ ಡೋಂಟ್ ಗಿವ್ ದಟ್ ಮಚ್ ಪ್ರಿಫರೆನ್ಸ್. ಈಗ ಹೈ ಇಂಪಿಡೆನ್ಸ್ ಇತ್ತಂದ್ರೆ ದಟ್ ವಿಲ್ ನಾಟ್ ಕ್ಯಾರಿ ದ ಎನಿಥಿಂಗ್ ಟು ದ ಫರ್ದರ್, that will not carry the anything to the further. Impedance is nothing but that will not carry the any to the input as the further one. Impedance is nothing but that is like a resistors. In the electrical or electrical side, we have seen the resistors which will force to oppose to the flow of current. Now similarly here also high impedance is nothing but in the digital system. If I use the high impedance type, then there is a weakest signal we will get. What type of signal? Weakest signal, not a highest, the strongest signal illa. Weak type irtada impedance ittandre, andre that is will not have the any effect on what the here. We will show the each and everything in the when we give the start simulation of waveform, there will get the Z ಅಂತ ಬರ್ದಿರ್ತದ. Z ಈ ತರ ಬರ್ದಿರ್ತಾರೆ. ಇದೇನಿರ್ತದ? ಇದ್ರೊಳಗೆ Z ಅಂತ ಬರ್ದಿರ್ತಾರ. ಅಂದ್ರೆ this is what the impedance one which is having the weakest energy. We don't have any impact on our digital system ಅಂತ ಅರ್ಥ. Okay, digital system ಅಂತ. This is what the these are the value sets are how many? Four are there. 8 types of what the strengths are there. 8 types of strengths are there. This one we already seen in the last class. Okay. If I two signals are equal strengths, then the definitely the stronger signal will be. If equal strength is condition number 1. Condition number 1 dagenutta. If I have the two signals are what the equal strength idre enagutta, stronger one sigtada. Stronger one. Enutta stronger one signal will be prevailed. Stronger one. Okay. If I have the two signals of the unequal one. Sorry. Sorry. If my two signals are, if two signals are what the two signals are unequal idre enagutte stronger one bartade. Equal idre enagutte not a stronger. Equal idre enagutte if my two signals are equal, there is no stronger one. Okay, we will not have the we have which type of one? This was the unknown. Either it would be what the unknown value. Unknown is nothing but the x. It is to be what the 0 or 1. ಈಗ unequal ಇದ್ದು ಅಂತ ಇಟ್ಕೋರಿ. Unequal ಇದೆ ಅಂದ್ರೆ ಇದು ಒಂದು ಸಿಗ್ನಲ್ ಐತೆ, ಇದು ಒಂದು ಸಿಗ್ನಲ್ ಅದ. Okay, we have the two signals here. For example, I have the two signals as okay. These are the two signals. One signal. I am also supplying the with the one more two unequal signals are there. Unequal signal. Unequal. Okay, we don't have the equal portion here. Unequal one. Then there is a definitely the output of this combination will get what the stronger one. Stronger one will get. If the both signals are equal one, if the both signals are what the equal one, then there will get the what type of output here? Unknown value. Unknown is nothing but the x. X can have the 0 or 1 value here. 0 or 1 value. That's nothing but these are the two conditions in what if I use these signals, okay, for the strength purpose also. Okay, this is all about the value set and the strength type. Value set and the strength type. When use of the value set is nothing but this is the only one two in order to describe the signal strengths. Okay, signal strengths only. Okay. Next one is what the nets. Again, just I am recalling the things here. Just I am recalling the things faster way. In faster way, I will recall the things. Okay, next is what the nets. Nets are nothing but these are the interconnection between the two logics or two gates or any digital design system. Okay, nets are nothing but these are what the hardware elements. Okay, these are the what the hardware elements connection between the hardware elements connection. Between the hardware element connections use ಮಾಡ್ತೀವಿ. These are the nets are nothing but the wires. These are also called as the sometimes wires also, and also these are used only when between the two logic gates or two logic gates or two digital design systems. Okay, usually the keyword for the nets is what the wire ಅಷ್ಟೇ. wire ಸಾಗಬಾರ್ದು, wire ಅಷ್ಟೇ ಯೂಸ್ ಮಾಡಬೇಕು ಕೀಬೋರ್ಡ್. Okay, for example, if I consider that one of the logic digital design system having the 4 inputs A, B, C, D. What is this one? AB plus of CD. Okay, this is what the Y. This is what the Y. These are the inputs. These are the output is there. These are the 4 inputs. This is only what the output is there. But the interconnection between the gate to gate we call what the nets. This we call what the nets. We can tertive nets. But in order to define in our Verilog HDL, these nets are defined with the one keyword that we call the wire. That we call the wire. These nets can be named as the N1 and even N2. Any name you can give. Wire, if I define the keyword with the wire, definitely the wire would be, how many wires are there? N1, N2 also you can use here. Like this. This is the way of using the nets. Okay. Nets can have the values. Okay. Nets can have the values. Output of the first. Okay. Output of this first logic gate is we consider for the value. What is the value? This is the net can have the values as the binary value. What's that binary value? Binary value. Binary of what the one bit of binary of either 0 or 1 bit of binary of 1. It can have the two values either 0 or 1. This is what the 1 bit binary value. It can have the output value here. Net then value only single value. That's what the binary bit form. That's because the either it is 0 or 1. What is the output of this AND gate? Only one. Either it is a 0 or 1. Either it's to be what the same. It's the same here. It's nothing but the wires can carry the only one single bit of information having the 0 or 1 value. Okay. Next one is this. These nets can be also have the default value net. Default value of this net is what the 1. Always 1 default value. Okay, always 1. It can also have the values as the 0, 1, X and also even Z also it can have either. Okay, usually the values are what the 0 or 1. Default value is what the 1 only. default value 1 ಇರ್ತದೆ. ಆದ್ರೆ you should remember the net can have the only single bit. ಸಿಂಗಲ್ ಬಿಟ್ ಇದೆ, 0 ಅಂದ್ರೆ ಸಿಂಗಲ್ ಬಿಟ್ ಇದೆ, 1 ಅಂದ್ರೆ ಸಿಂಗಲ್ ಬಿಟ್ ಇದೆ, x ಅಂದ್ರೆ either 0 ಇರ್ಬೋದು ಒಂದು, ಇಲ್ಲ 1 ಇರ್ಬೋದು ಒಂದು. Impedance also having the same as the it's 1 bit only. That's nothing but the nets can have the single bit of information. Default value is what the 1 only. It can have the 4 values as the 0, 1, x and z also. Okay, this is all about the nets. If you don't have the any drivers if you don't have the any driver in before this net, we can say it's what the net can also have the z value. Z is nothing but the impedance. Other driver ಇಲ್ಲ ಅಂದ್ರೆ ಏನು ಅದಕ್ಕೆ ಏನಿಲ್ಲ ಅಂತ ಅರ್ಥ. If you don't have the any energy over that one, okay, that's what the if it is don't have any drivers, okay, then the definitely the output of the value of this net is always with what the z only, not a 0, not a 1. Next one is what the resistors. Just I am recalling the things. Just I will complete the all the 8 types of data types here. 8. Okay. Next is what the resistors. Resistors are nothing but these are the storage elements. These are the storage elements. These are the storage elements. These are used to store the output value. These are used to store the what the output value. Okay. The keyword for the resistor is what the REG. The keyword for the resistor is what the REG. Okay. Resistors do not have the any drivers here. But nets again ಬೇಕಾಗಿರ್ತದೆ, driver ಬೇಕಾಗಿರ್ತದೆ. Driver ಇರ್ಲಿಕ್ಕಂದ್ರೆ value ಏನಿರ್ತದೆ, impedance ಆಗುತ್ತೆ, Z ಆಗುತ್ತೆ. Okay, compulsory. But here the resistors don't need any drivers here. Any drivers. We don't need any drivers here. We don't need any drivers here. And also we have the default value of this resistor is what the value x only, x, either it's what the resistor value is what the REG. Default value of this resistor is having the what the x is nothing but the unknown value. It's to be what the 0 irbodu, 1 irbodu. Okay, resistors variables must be initialized with the always keyword. This always it is to be used with the help of what the keyword as the initial keyword ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಬೇಕು. ಒಂದು ಇನಿಷಿಯಲ್ ಬರ್ದು ಅಲ್ಲಿ ರೆಜಿಸ್ಟರ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಇನಿಷಿಯಲ್ ಬರಲೇಬೇಕು. Or else even you can also use instead of this initial, you can also use what the always at the rate, always, yes, it may be always at the rate something we are writing there in the while block is what the begin and end. This is what the end of the model. We have seen in the writing a program with the help of what the behavioral model. There we will be using the register is what the register is used to what the initial indicate what the output value. There we have seen in the digital design system y was the what the output there. Register equals to y, inputs are what the a b c d. Okay, register is what the y. Initial ಬರೆದ್ಮೇಲೆ initial ಅಲ್ಲಿ ಬರೀಲ್ಲ at the rate of always at the rate ಅಂತ ಬರೀಬಹುದು. Either of one you can use. Then you have to write the begin. You have to write the some logic in between this one, begin and end. This what the using what the register keyword for the our storage purpose. Okay, it's what the default value is what the x only. Okay, next is what the consider the vectors. Usually the inputs are always sent with what the single one. Okay, if I am sending the inputs only what the single one, then definitely I can use what the that keyword itself. For example, if I am sending the wire only one, the having the inputs as the only one bit, that's what the we can say is what the wire is having the only the one. Register, if I am sending the register, if I am sending the register value, okay, that's having only what the one bit idra register x ಅಂತ ಬರಿಬಹುದು, y ಅಂತ ಬರಿಬಹುದು, 1 ಅಂತ ಬರಿಬಹುದು, ಏನಾದರೂ ಬರಿಬಹುದು. If it is having the multiple number of bits, if I am going to send the multiple number of bits, definitely I go with what the vectors. Vectors are nothing but this is what the multiple bit width, multiple bit width, okay, multiple bit width, okay. Nets are here we can say is what the nets are resistors. Nets are nothing but the wires. If you want to define the nets with the single one, definitely I can say what the wire one like this. If you want to define the if you want to send the multiple bits, definitely the nets and resistors always go with what the vectors form. This is what the value. This vectors can be defined with the two values as the I hash of I and the hash, high hash, comma, low hash, or else you can also define the even you can also define the low hash, comma, high. It means here the what the value here the it's if it is having the 4 bit. If you want to send the 4 bit value, definitely I can define with what the 3:0. Means what the 4 bit form. It has the wire resistor is having the 4 bit of information. If I said I resistor y, if I send the resistor y, a resistor equals to y, then the y can have the which value? X. Either it is a 0 or 1. Now 0 or 1 ಅಂತ ಕಳಿಸ್ತೀವಿ. ಏನು ಇರ್ತವೆ ಎಷ್ಟು ಬಿಟ್ ಅವ? Single bit ಅದ, ಒಂದೇ bit. If you want to send with the multiple bit, then definitely I have to go with what the resistors square bracket use ಮಾಡೋ compulsory. Square bracket 3:0. It means here the what I am using here the resistor can have the 4 bit of information. It's where the 4 bit of information. Vectors are nothing but the multiple width. Even we can also use the this multiple width value toward the nets also. Nets are nothing but the wires also. If I go with the, if I define the wire, 7:0. This is what the wire. If I have the number of, if only one wire idre anantidhi, wire antidhi adaka, single idde wire antidhi. If I wires with the multiple numbers are there. We can see what the how many are there? 7, 8 are there. 1, 2, 3, 4, 5, 6, 7, 8 are there. This is what the multiple numbers we can sort the bus. We can see what the multiple number of wires we can sort the wire. Wire of 7:0 bus is there. Bus. This is what the declaring what the we can say we can define. This is what the declaring of the 8-bit net. Wire is nothing but net only. Wire is nothing but net bus. Which is what the declaring of what the 8-bit net bus is there. 8-bit net bus is there. Similarly, we can define the wire of what the 3:0. Bus A, bus B, and bus C. This is what the each bus A, bus B, bus C having the what the value of the only 4 wires are there in this one, having the values as the 0:3, 3:0, 3:0, 0:3 ನು ಬರಬೇಕು, 3:0 ನು ಬರಬಹುದು. But there some conditions are there. ಯಾವಾಗ ಹೆಂಗ್ ಬರೀಬೇಕಂಬ we'll see that one. There are 2 types of vectors. I'll explain that one. This is what the vector declaration. Vector, okay. Even the resistors also we can use the resistor 0 to 40. This is what the value is what the output value we are defining here. Output of our my digital system having what the 0 to 41 bit. This is what the having the output of resistor value is what the 41 bit of information. Like this we can declare, okay, about the vectors. Okay, this is all about vector. Okay, there are 2 types of vectors. From this one we can define it's what the there are 2 types of vectors. One is what the vector part selector. Another one is what the variable vector part selector. That one we'll see. That one today will the till now we have seen. Today we'll start with the this one only. Vector ಅಂದ್ರೆ ಗೊತ್ತಾಯ್ತಲ್ಲ. Okay, vector is nothing but the multiple bit width. In this there are 2 types of vectors are there. One is what the vector part select. vector part select. Another one is what the variable. This is the same vector part select only. Variable vector part select only. One is what the vector part select. Another one is what the variable vector part select. Variable vector part select. Okay, variable vector part select. First one we consider the vector part select. Vector part select. Vector part select andre enagutte. What is this one is if I have the vector part, okay, if it's a wire of that what 7:0 a bus was there. ನಾನು ಅಷ್ಟು ನಾನು ಸೆಲೆಕ್ಟ್ ಮಾಡೋದಿಲ್ಲ. ಆ ಬಸ್ನಾಗ 7:0 ಬಸ್ ಇದೆ ಅಂದ್ರೆ 8 ಬಿಟ್ಸ್ ಆಫ್ ಬಸ್ ಇದೆ, ವೈರ್ಸ್ ಇದೆ. ಅದ್ರಲ್ಲಿ ನನ್ಗೆ ಏನ್ ಬೇಕಾಗಿದೆ, ಬರೀ ನನಗೆ ಸಿಂಗಲ್ ವೈರ್ ಬೇಕಾಗಿದೆ. ಯಾವುದು 7th ವೈರ್ ಬೇಕಾಗಿದೆ, ಇಲ್ಲ 6th ವೈರ್ ಬೇಕಾಗಿದೆ. ವೆಕ್ಟರ್ ಪಾರ್ಟ್ ಆ ಪಾರ್ಟ್ ನಾಗ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತದೆ. ವೆಕ್ಟರ್ ಏನಿರುತ್ತೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹಿಯರ್ ದ ಬಸ್ wire is there, wire 7:0 bus is there. Yes sir, it is completely defining what the vector there. In this one I have to select only part of this vector. I have to take this one. Okay, I can define with what the bus or bus. We can give the any name here for this A and the berry, B and the berry, another berry. But I want to select from this one only what the cell only what the 7th only. This is what the bit of 7th vector. We can say it's what the bit of 7. Okay, bit of 7 vector, bit of 7 vector, bit 7. Okay, sorry, bit 7 of vector bus selection. We can give the name as the bus A ಅಂತ ಬರಿಬಹುದು. bus A ಅಂತ ಬರೀರಿ. bus A vector bus A. Okay, bus A. E1 you can also select the bus 2:0. 2:0 ಅದಾನು ಇಲ್ಲ, 2:0 ಅದ ಇಲ್ಲ. 0 to 3 ಇರಬಹುದು, ಯಾಕ 4 ಬಿಟ್ ತಗೋಬಹುದು. 0 to 7 ತಗೋಬಹುದು, ಇಲ್ಲಾಂದ್ರೆ 0 to 16 ತಗೋಬಹುದು. ಈ ತರ ಇರುತ್ತೆ. ಬಟ್ ನನಗೆ ಎಷ್ಟು ಬೇಕಾಗಿದೆ ಈಗ, ಓನ್ಲಿ 3 ಬಿಟ್ಸ್ ಬೇಕಾಗಿದೆ. 0 1 2 0 1 2 ಇಷ್ಟೇ 3 ಬಿಟ್ ಬೇಕಾಗ್ಯಾವ. ಅದ್ರ ಸೆಲೆಕ್ಟ್ ನಾನು ಏನ್ ಮಾಡ್ತಿದ್ದೀನಿ, ಫ್ರಮ್ ದಿಸ್ ವೈರ್ ವಿ ಕ್ಯಾನ್ ಸೆಲೆಕ್ಟ್ ದ ಬಸ್ ಆಫ್ ಎ ಅಂತ ಬರೀರಿ, ಏನಾದ್ರು ಬರೀರಿ ಬಸ್ ಫ್ರಮ್ ದ ಬಸ್ ಎ. ಓಕೆ, ಇಸ್ ವಾಟ್ ದ ವೈರ್ ಐ ಗಿವನ್ ನೇಮ್ ಆಸ್ ದಿ ಬಸ್ ಎ ಅಂತ ಬರೀರಿ, ಪರವಾಗಿಲ್ಲ. ಬಸ್ ಎ ದಾಗ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಓನ್ಲಿ 3 ಬಿಟ್ಸ್ ಐ ಆಮ್ ಸೆಲೆಕ್ಟಿಂಗ್ ಹಿಯರ್. It is nothing but the vector part selection we are doing. What here this is what the complete vector. From this vector only we are selecting the part of this for my programming here. This is bus A vector of 0 to 3, 2:0 is nothing but only 3 bit selection we are doing. 3 least bit, 3 least 3 LSB ಅಥವಾ 3 least bit, least significant 3 least significant bit of bits of bus, 3 bits of vector bus. Only what we did here, only what the bit 7th is we have selected here. If you want to have the more, okay, 0 to 4 irutte, 0 to 4 irutte, ಅದರಲ್ಲಿ ನಾವು only 3 ಅಷ್ಟೇ ಸೆಲೆಕ್ಟ್ ಮಾಡೋದು. ಇಲ್ಲಿ ಎಷ್ಟಿದೆ, 0 to 7 ಅದ, 8 ಬಿಟ್ಸ್ ಅದ. ಅದರಲ್ಲಿ 8 ಬಿಟ್ಸ್ ಎಲ್ಲ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, how many bits, only 3 bits which are having the three least significant bits of the vector bus A we are selecting here like this. This is nothing but the vector part selection. ಈ vector part selection ಗೊತ್ತೈತಿ. In this from this one more is that, what is that, variable is there. Variable vector part selection. Variable ಇರಬಹುದು. ಯಾವ ತರ ತಗೋಬಹುದು ವೇರಿಯಬಲ್ ವೆಕ್ಟರ್ ಪಾರ್ಟ್, ಐದರ್ ಇಟ್ಸ್ ವಾಟ್ ದ ಇನ್ಕ್ರೀಸಿಂಗ್ ಇರಬಹುದು, ಡಿಕ್ರೀಸಿಂಗ್ ಇರಬಹುದು. ಇದೇನಿರುತ್ತೆ, ಇನ್ಕ್ರೀಸಿಂಗ್ ಆಗಬಹುದು ಅಥವಾ ಡಿಕ್ರೀಸ್ ಆಗಬಹುದು. ಅದಕ್ಕೆ ನಾವು ಏನು ಕರಿತೀವಿ, ವೇರಿಯಬಲ್. ಇಫ್ ಐ ಯೂಸ್ ದ +1 then that will be what's the increasing one. If I use the -1 in this only, that will become what the decreasing one. Okay, that becomes what the decreasing one. We'll see that one. Okay, variable HDL provides the ability to have the variable parts in this selection, which are having what the variable one. Okay, it's a varying one. This allows the part of selection even the put into what the decreasing one and even increasing one also. We can put the in the loop form also. There are two special part of selective operators. One is for the string. This one, okay, we consider the variable part selection. String of the string bit, what the positive plus width, okay. Okay, next is what the string bit, underscore, string bit, minus alla, string bit, negative, okay, semicolon, colon akre, semicolon alla, colon, width, okay, width of the what the square bracket. This is what we are bringing here, the decreasing one. This is what the variable parts. This is what the variable vector, same variable vector part selector. ಮೊದಲು ಏನು ಮಾಡ್ತೀವಿ, ವೆಕ್ಟರ್ ಪಾರ್ಟ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಆ ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಪಾರ್ಟ್ ಒಳಗೆ ವೇರಿಯಬಲ್ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ, ಪಾಸಿಟಿವ್ ಆಗಿ ನೋಡಬಹುದು, ನೆಗೆಟಿವ್ ಆಗಿ. ಪಾರ್ಟ್ ಸೆಲೆಕ್ಟ್ we can have the part selection in the increments from the string bit. This is what we can sort the part selection in the what the increasing increments from the string bit, increasing increments from string, okay, increments from string bit, okay, increment ಆಗುತ್ತೆ. This is what the part selection, this is what the increments alla decrements ಅಂತ ಬರೀಬೇಕು. Decrements from string bit, okay, from string bit. ಇದೆಲ್ಲ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಹೇಳು, ಫಾರ್ ಲೂಪ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ದಿಸ್ ಟೈಪ್ ಆಫ್ ವೇರಿಯಬಲ್ಸ್ ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ವಿಲ್ ಬಿ ಯೂಸಿಂಗ್ ವಾಟ್ ದ ಇನ್ ದ ಫಾರ್ ಲೂಪ್. ಫಾರ್ ಲೂಪ್ ಏನಾಗುತ್ತೆ, ಐದರ್ ಇಟ್ಸ್ ಡಿಕ್ರೀಸಿಂಗ್ ಒನ್ ಆರ್ ಎಲ್ಸ್ ಇಟ್ಸ್ ವಾಟ್ ದ increasing one. It's we can use this type of variable vector part selection will use in the for loop one, okay. For example, byte, for example, byte of equals to data 1 2a ಬರಬೇಕಿದೆ, 2a plus colon 8. This is what the starting bit of this one is what the this byte information starting bit is what the 2a. This what the 2a ಎಲ್ಲಿ ತಕ್ಕ ಇನ್ಕ್ರೀಸ್ ಆಗಬಹುದು, 8 ಬಿಟ್ಸ್ ತಕ್ಕ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು. ಹೆಂಗ 8 ಬಿಟ್ಸ್. ಎ ಆದ್ಮೇಲೆ ಏನ್ ಬರ್ತದೆ, ಎ ಆದ್ಮೇಲೆ ಅಂತ ಎ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಬಿ ಸಿ ಡಿ ಇ ಎಫ್ ಜಿ ಎಚ್ ತಕ್ಕ 8 ಬಿಟ್ಸ್ ತಕ್ಕ ಇನ್ಕ್ರೀಸ್. 2a ಸ್ಟಾರ್ಟಿಂಗ್ ಅಡ್ರೆಸ್ ಇಸ್ ವಾಟ್ ದ 2a ಅದ ಸ್ಟ್ರಿಂಗ್, ಅದು ಎಲ್ಲಿ ತಕ್ಕ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು, 8 ಬಿಟ್ಸ್ ತಕ್ಕ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು. ದಿಸ್ ಇಸ್ ವಾಟ್ ದ ಸ್ಟಾರ್ಟಿಂಗ್ ಬಿಟ್ ಇಸ್ ವಾಟ್ ದ ಬರ್ಕೋಬೇಕು. ಇಲ್ಲಿ ಬರ್ಕೋರಿ, ಕಮೆಂಟ್ ಅಲ್ಲಿ ಬರ್ಕೋರಿ. ಸ್ಟಾರ್ಟಿಂಗ್ ಬಿಟ್ ಇಸ್ ವಾಟ್ ದ starting bit is 2a and it's what the 2a and width is what the width is given as the 8 bits. ಇದರ ಆನ್ಸರ್ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ, ಸಾರಿ 24 ಬರ್ರಿ, 2a ಅಲ್ಲ 24 ನಿಂದ ಇನ್ಕ್ರಿಮೆಂಟ್ ಎಷ್ಟಾಗುತ್ತೆ ಹೇಳ್ರಿ. ಇದೆ 24 ನಿಂದ ಇನ್ಕ್ರಿಮೆಂಟ್ ಎಷ್ಟಾಗುತ್ತೆ, 24 25 26 27 28 29 30 31. ದಿಸ್ ವಾಟ್ ದ ಸ್ಟಾರ್ಟ್ 24 is to 31. ಹಿಂಗಾದ್ರೆ ಬರೀಬಹುದು. ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕು, ಇಲ್ಲ ಸ್ಟಾರ್ಟಿಂಗ್ ಆರ್ ಎಲ್ಸ್ ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ರೈಟ್ ವಾಟ್ ದ 31 is to 24 ಬರೀಬಹುದು. ಹಿಂಗಾದ್ರೆ ಬರೀಬಹುದು, ಹಿಂಗಾದ್ರೆ ಬರೀಬಹುದು. ಇಟ್ ಮೀನ್ಸ್ ದಿಸ್ ವಾಟ್ ದ ವಾಟ್ ಆರ್ ವಿ ಗಿವಿಂಗ್ ದಿಸ್ ವಾಟ್ ದ ವಿಡ್ತ್. ದಿಸ್ ವಾಟ್ ದ ಸ್ಟ್ರಿಂಗ್ ಬಿಟ್, ಸ್ಟಾರ್ಟಿಂಗ್ ಸ್ಟ್ರಿಂಗ್ ಬಿಟ್, but here the starting string bit ಆಗಿರುತ್ತೆ, ಕರೆಕ್ಟ್ ಅದ. ಬಟ್ the width is mentioned here the next to this one. ಈಗ ನೋಡ್ರಿ, ನೆಕ್ಸ್ಟ್ ಏನ್ ಬರೀತೀವಿ ಈಗ, 2 raised to plus of 6 ಬರೋದಂತ ಇಟ್ಕೋ. ಇದು ಎಷ್ಟಾಗ್ಬೋದು ಆನ್ಸರ್, ಇದು 2 ಸ್ಟಾರ್ಟಿಂಗ್ ಅಡ್ರೆಸ್ ಇಸ್ ವಾಟ್ 2 raised to 6 ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ ಇನ್ಕ್ರಿಮೆಂಟ್, 6 ಆದ್ರಾಗ 8 2 raised to 8 ಆಗ್ತದೆ. This is what the answer, it's the increment 1. It's what the increment 1. This type of, okay, if I use the decrement type also. If I use the decrement type also, we have the decrement type of 31. Okay, for example, 31 byte of equals to data. Okay, data. Okay, 31 minus of 8. This is what the answer we are getting here. What type of answer we can get here? Starting bit is what the 31. Okay, end bit is what the 24 only. 31 raised to 24. 31 in the decrement mark 31, 30 like this. Okay, we'll give the answer is what the 31 raised to 24. This is what the high to low. We are using what the low to high is low idinda high tak martide ಇಲ್ಲಿ high ನಿಂದ low ಬರ್ತದೆ ಅಂದ್ರೆ decrement form. This is what we use here what the -1. This one is what is for the variable vector part selected. Variable vector part select. Did we select any completely variable complete vector form select ಮಾಡಿದನ ಇಲ್ಲ vector part select ಮಾಡಿ complete vector select ಅಂತ ಮಾಡಿಲ್ಲ vector part select ಮಾಡಿ in that we are using what the variable vector form, either it's what the increasing one or else it's what the decreasing one. These type of vectors variable vector forms are used in what the for loops where we will use the in the for loops we are using here. This type of vector forms we use what the for loop. For example, I will show that one. Just you write down that one. For example, starting bit can also be variable. In this case, width has no width as the constant one. Constant one. Example is here the for loop I am using here j equals to 0. J equals to 0 semicolon. Okay, j is what the less than or equal to what the 31. And also it's to be incremented. J always incremented with how much? J plus of 4. It has to be incremented how much? 4. It has to be incremented with what the 4, not a plus 1. This is what the increment type of. What's the increment of what the variable vector form you are using here. Okay, this is what the answer is would be what here the byte of data. Byte equals to data. Byte equals to data 1, we can say it's for the 1, but here the j multiply with what the 8 plus of interest 8. This is what the answer would be. What here the answer? Tell me the sequences. What type of sequence we are getting here? This is one example. For loop name use marte. This is the another example we'll be using. What is the output of this one? J plus of 8 introduced 8. J 0 ಹಾಕಿದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ? J 0 ಹಾಕಿದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ? 0 raised to 8. J 1 ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ? 8 raised to starting address what the 8 bits. So it should be length should be have the what the 8 bits. That's nothing but 0 raised to 7 8 bits. Width ಎಷ್ಟದ ಇಲ್ಲಿ? Width ಎಷ್ಟದ ಇಲ್ಲಿ? 8 ಅದ. 8 ಅಂದಾಗ ಏನು ಬರಬೇಕು ಇಲ್ಲಿ? 0 ಹಾಕಿದಾಗ ಏನು ಬರುತ್ತೆ? 0 raised to 7. It's nothing but 8. 0 to 7 ಎಷ್ಟಾಗುತ್ತಾ? Width ಎಷ್ಟಾಗುತ್ತಾ? Width ಎಷ್ಟಾಗುತ್ತೆ? 0 1 2 3 4 5 6 7. 8 bits 8 width ಆಗುತ್ತಲ್ಲ. Similarly, we can also write this one is what the 7 raised to 0 ನು ಬರಿಬಹುದು ಅಥವಾ 0 raised to 7 ನು ಬರಿಬಹುದು. Next is what the 8 raised to 15. Yes sir. Next is what the 15 raised to what the 24. Like this it should have the what the width is what the always increasing what the 8 only. It's what the type of here we are mentioning is what the width 8. But here also we are mentioning here the increment is always with what the 4 bits. Here the 4 mention marti ee tara mention ಮಾಡಬಹುದು, or else we can also mention this. Okay, there are 2 examples are there. For loop ne one hinge irtida, another one is this one is too. Okay. Okay, in this one we can initialize this is completely idena bartada for one loop bartada complete agi we will get the so many numbers here. Okay, 24 is to 31 like this, 31 is to like this, we'll get the initialize with the so many numbers. But we want to select the only part of this one. What this one, if you want to select the only part of this one, then we can go with what the data 1 byte of num type. This is the num type. Okay, this nothing but the 8 plus of is to 8 equals to what the 8 bits of 0 1, 8 bits of 0 1. ಯಾವ್ದ್ರಿ 0 to 7, 8 to 15, 16 to what the 16 to 23 na? No. 16 to what the 23. Okay, done. Sorry. Okay, like this. But the data, if you want to select the among this data, if you want to part of this selection, if you go with what the part of this one. Okay, byte of num is to 8 into multiply with the 8 with the 8 is to, this is what the 8 is to 8 bits of data which is having the 0 because of the initial value is what the 0. If I go with the byte num is what the 1 ಕೊಟ್ಟನ ತಿಟ್ಕ 1 ಕೊಟ್ಟಾಗ ಏನಾಗ್ತದೆ ಇದು 0 is to 8 ಆಗುತ್ತಾ, ಇದು ಆಗಲ್ಲ, ಏನಾಗುತ್ತಾ 0 is to 7 ಆಗುತ್ತಾ. ಇದು ಪಾರ್ಟ್ ಆಫ್ ದಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಮೆನ್ಷನ್ ವಿತ್ ವಾಟ್ ದ ಬೈಟ್ ನಮ್ ಏನ್ ಕೊಡ್ತೀವಿ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರ್ತದೆ. ಇದ್ರ ಮೇಲೆ ಈಗ ಪಾರ್ಟ್ ಆಫ್ ದಿಸ್ ಒನ್ ವಿ ಕ್ಯಾನ್ ಸೆಲೆಕ್ಟ್ ಇಟ್ಸ್ ಫಾರ್ ದ ಬೈಟ್ ನಮ್ ಏನ್ ಇರ್ತದೆ 0 ಕೊಟ್ಟರೆ ಏನಾಗುತ್ತೆ ಕಂಪ್ಲೀಟ್ಲಿ 0 to 7 ತಗೋತೀವಿ. ಒಂದು ವೇಳೆ ಬೈಟ್ ನಮ್ ಏನ್ ಕೊಡ್ತೀವಿ 1 ಕೊಟ್ಟ ಅಂತ ಇಟ್ಕೋರಿ, 1 ಕೊಟ್ಟಾಗ ಏನಾಗುತ್ತೆ ಇದು ಡಬಲ್ ಏನಾಗುತ್ತಾ 8 is to 1. ಇಟ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ಹಿಯರ್ ದ 8 ಏನಾಗುತ್ತೆ 8 ಏನಾಗುತ್ತೆ ವಿತ್ ದ ಆಡ್ ಮಾಡಿ 8 ಸಲ ಆಡ್ ಮಾಡ್ಬೇಕು. ಇದು ವಿಡ್ತ್ ಎಷ್ಟು ಆಡ್ ಮಾಡೋ 8 16. Okay, 8 is to 16 ಆಗುತ್ತೆ. Like this will be having the part of the vector form will be selecting one with the help of what the with one. Okay, even we can use the variable vector part selection, even the part vector selection also will have the, we can use both. Okay, in this one. Next is what integer. Okay, time aita only fast I'll be teaching. Okay, barabagada. Okay, one nisha. Okay, fast will be teaching. Okay, integer, fifth one is what the integer, real, and also time type of data types. Time type of data types. There are, this is the one. Okay, integers are used what the is the general purpose registers data type which are used for the integer keyword is what the penna model aitu. Okay, these are used for the manipulating the data type, manipulating the data. Integers are used for the manipulating the data, and also used for the integers are declared always with what the one keyword, that's for the integer. Okay, integer, small cap, small and integer keyword, and also with these are the used for the purpose of for the counting purpose. These are used for the purpose of for the ಕೌಂಟಿಂಗ್ ಪರ್ಪಸ್. ಇವೆಲ್ಲ ಕೌಂಟಿಂಗ್ ಪರ್ಪಸ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಮ್ಯಾನಿಪ್ಯುಲೇಟಿಂಗ್ ಡೇಟಾ ಮಾಡ್ಬೇಕಾದ್ರೆ ಇಂಟೀಜರ್ ಇಂಟ್ ಟೈಪ್ ಏನ್ ಮಾಡ್ತೀವಿ, ಇಂಟ್. ಆಮೇಲೆ ಇದು ಕೀವರ್ಡ್ ಏನಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಇಂಟೀಜರ್ ಅಂತ ಮಾಡ್ತೀವಿ. These are used for the counting purpose, and also these are the what the integer default width of this integer is what the in the usually the at least the 31 bits. 31 bits ಇರ್ಬೇಕಂದ್ರೆ 0 to 32 bits ಇರ್ಬೇಕು compulsory. Default value of the integer is what the 32 bits only, you should remember. Okay, and also we have there are the different types of integer, either it's what the positive type or else it's what the negative type ನೇ ಇರಬಹುದು. ಇಂಟಿಜರ್ ನಲ್ಲಿ ನೆಗೆಟಿವ್ ನಂಬರ್ ಇರಬಹುದು ಮತ್ತು ಪಾಸಿಟಿವ್ ನಂಬರ್ ಇರಬಹುದು, ಪಾಸಿಟಿವ್ ನಂಬರ್ ಇರಬಹುದು. ನೆಕ್ಸ್ಟ್ ಇಸ್ ವಾಟ್ ದ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಡಿಕ್ಲೇರ್ ಓಕೆ ಇಂಟಿಜರ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ integer count always start with what the start. Okay, initialize integer, initial count equals to -1. -1 ಇಂದ ಕೌಂಟ್ ಮಾಡಕ್ ಹೇಳ್ತಾರೆ, +1 ಇಂದ ಕೌಂಟ್ ಮಾಡಕ್ ಹೇಳ್ತಾನೆ. ಇಟ್ಸ್ ವಾಟ್ ದ initial integer count. Okay, this is what the initial we are using, initial keyword. Okay, initial is nothing but it should be what the output purpose. Okay, ಇಲ್ಲಿ ನಾವು initial ಬದಲಿ at the rate always ಯೂಸ್ ಮಾಡಬಹುದು initial. Okay, count -1 ಅಂದ್ರೆ ಡಿಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ನೇ ಹೋಗ್ತದೆ, -1 ಇಂದ ಕೌಂಟ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. Okay, store the -1 in the integer variable count. This is what the integer type. Another one is what the real one. Real ಅಂದ್ರೆ ಏನು ಇರ್ತದೆ ಹೇಳ್ರಿ? Real numbers ಇರ್ತಾವ. It's real numbers are can be ಯಾವ್ದ both, either it's what the positive number or negative number. Real number ಹೆಂಗ್ ಬರ್ತೀರಿ? real number ಹಿಂಗೆ ಬರ್ತೀರಿ. real number imaginary type ಅವು ಅವಕ್ಕೆ real numbers ಅಂತಾರಿಲ್ಲ. It can have the both values, either it's what the positive or negative number. Real numbers constants can have the registers data types which is be declared with what the keyword is what the real keyword ಇಂದ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಒಂದು ಇಂಟಿಜರ್ ಟೈಪ್ ಇತ್ತಂದ್ರೆ int ಅಂತ ಮಾಡ್ತೀವಿ, either it's what the positive or negative number integer. If it's a real type either it's what the positive number or negative number, then it is to be declared with the one keyword that is called the real one. Specifically if you want to mention the width of that one, what the, for example 3 of e6, how you will write 3e6 can be written as what the 3 into 10⁻⁶. It's what the real type. It can be you have the imaginary value or real type. ಇದು ಇದೇನಿರುತ್ತೆ ನೋಡ್ರಿ 5. ಇದೇನಿರುತ್ತೆ ಇದು this what the imaginary part, this what the real part can have the values, either it's what the 3e6 also. Real numbers count always start range in the declaration. Default value of the real number is what the 0 only. Default value of the real number is what the 0 only. Always real numbers are rounded to what the one value. Whenever it may be one number ಇರ್ತಂತೆ ಯಾವ್ದಾದ್ರು 0.5 something ಕೊಟ್ಟಿರುತ್ತೆ 15:6 ಇರ್ತದ. 15:6 ಇತ್ತಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಿ? ಇದಕ್ಕೆ ಇಷ್ಟು ವಾಟ್ ದ ಕೌಂಟ್ ರೌಂಡ್ ಫಿಗರ್ ಮಾಡ್ತೀವಿ. ಎಷ್ಟು ರೌಂಡ್ ಫಿಗರ್ ಮಾಡ್ಬೋದು? ಇದು 16 ಮಾಡ್ಬೋದು, ಯಾಕಂದ್ರೆ ಮೋರ್ ದೆನ್ 6 ಇರುತ್ತೆ. ಒಂದ್ ವೇಳೆ 15:2 ಇತ್ತಂತ ಇಟ್ಕೋ, ದಿಸ್ ಟು ಬಿ rounded to what the some values. This what the 15 only. Always real numbers are what the rounded to what the some values to be what the either it is what the increment on or else it should be what decrement. It should be always at the end it should be defined with what the integer only. Okay, next is what the sim arrays. Timestamp idana, real timestamp is also there. Variables Verilog simulation is also done with the requesting what the simulation time. ಈಗ simulation time ಕೊಡ್ತಿರ್ತೀವಿ. ಈಗ ವೇವ್ ಫಾರ್ಮ್ ನಿಂದ ಒಂದು ಸಿಗ್ನಲ್ ಇಂದ ಇನ್ನೊಂದು ಸಿಗ್ನಲ್ ಗೆ ಎಷ್ಟು ಡಿಫರೆನ್ಸ್ ಇರಬೇಕು. ಈಗ ನೋಡು ಎಲ್ಲದಕ್ಕೂ ಫಾಸ್ಟ್ ಟೈಮಿಂಗ್ ಕೊಟ್ಟಿವಿ ಅಂದ್ರೆ ಅಂತ ಫಾಸ್ಟ್ ಆಗಿ ಔಟ್ಪುಟ್ ತೋರಿಸೋದು ಕಣ್ಣಿಗೆ ಕಾಣಿಸಲ್ಲ. either it should be what the 1000 milliseconds, either it is what the 1000 nanoseconds also we can define. Which means what the in the simulation time ಸಿಮ್ಯುಲೇಷನ್ ಟೈಮ್ ಅಲ್ಲಿ ಒಂದು ಔಟ್ಪುಟ್ ಇಂದ ಇನ್ನೊಂದು ಔಟ್ಪುಟ್ ಗೆ ಟೈಮ್ ಡಿಫರೆನ್ಸ್ ಇರಬೇಕು. ಎಲ್ಲಾನು ಎಟ್ ಎ ಟೈಮ್ ಕೊಟ್ಟರೆ ಏನಾಗ್ತದ ಗೊತ್ತಾಗಲ್ಲ, ಒಂದೊಂದೇ ಡಿಸ್ಪ್ಲೇ ಮಾಡ್ಕೊತ ಬರ್ಬೇಕು. ಈಗ ವೇವ್ ಫಾರ್ಮ್ ಬರ್ತಿರ್ತದ, ವೇವ್ ಫಾರ್ಮ್ ಹಿಂಗ್ ಬಂದ ತಕ್ಷಣ ಹಿಂಗ್ ಬರ್ತಿರ್ತದ. ಬಟ್ ಇಟ್ ಶುಡ್ ಬಿ ದೇರ್ ಇಸ್ ಎ ಟೈಮ್ ಲ್ಯಾಬ್ಸ್. ಓಕೆ, ಇದು ಎಷ್ಟಿರ್ಬೇಕು ಟೈಮ್ ಎಂಬುದು ವಿಡ್ತ್ ಮೆನ್ಷನ್ ಮಾಡಿರ್ಬೇಕು. ಆ ಟೈಮ್ ಲ್ಯಾಬ್ಸಿಗೆ ನಾವು ಮೆನ್ಷನ್ ಮಾಡ್ತೀವಿ. ಒಂದ್ ವೇಳೆ ಎಷ್ಟು ನ್ಯಾನೋ ಸೆಕೆಂಡ್ಸ್ ಇರಬೇಕು, 1000 ನ್ಯಾನೋ ಸೆಕೆಂಡ್ಸ್ ಆರ್ 1000 nanoseconds or 1000 milliseconds. Always time will be initialized with the time keyword. That's the time equals to what the 1000 nanoseconds by the 100 nanoseconds, 10 nanoseconds. Like this we can define. In the what the simulation mada time ashte barta, real time al mention madadalla. The simulation part is nothing but the when we giving the multiple number of inputs, ಕೊಟ್ಟಿರ್ತೀವಿ, ಅದರಲ್ಲಿ ಕೊಟ್ಟಿರ್ತೀವಿ ಟೆಸ್ಟ್ ಬೆಂಚ್ ಅಲ್ಲಿ ಬರೀತಿರ್ತೀವಿ. ಟೆಸ್ಟ್ ಬೆಂಚ್ ಅಲ್ಲಿ ಇದು ವಿ ಹ್ಯಾವ್ ಟು ಮೆನ್ಷನ್ ದಿಸ್ ಒನ್. ಓಕೆ, ಇದರಿಂದ ಇದಕ್ಕೆ ಎಷ್ಟು ಡಿಫರೆನ್ಸ್ ಇರಬೇಕು, ಈ ಔಟ್ಪುಟ್ ನಿಂದ ಈ ಔಟ್ಪುಟ್ ಗೆ ಎಷ್ಟು ಡಿಫರೆನ್ಸ್ ಇರಬೇಕು, ಈ ಫಾರ್ಮ್ ನಿಂದ ಈ ಫಾರ್ಮ್ ಗೆ ಟೈಮ್ ಗ್ಯಾಪ್ ಕೊಡ್ಬೇಕು, ಡಿಲೇ ಕೊಟ್ಟಿರ್ಬೇಕು. ಡಿಲೇ ಕೊಡ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಹೇಳು, ಔಟ್ಪುಟ್ ಒಂದ್ರ ಮೇಲೆ ಕೂಡ್ತಾವೆಲ್ಲ, ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಕೂಡ್ತಾವ. ಟೈಮ್ ಡಿಲೇ ಕೊಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ಒಂದು ಡಿಸ್ಪ್ಲೇ ಆಗಿದ ತಕ್ಷಣ ಇನ್ನೊಂದು ಡಿಸ್ಪ್ಲೇ ಆಗ್ತಿರ್ತದೆ, ಔಟ್ಪುಟ್ ಕೊಡ್ತಿರ್ತದೆ. ದಿಸ್ ಒನ್ ವಿ ಗಿವ್ ದ ಇನ್ ದ ಸಿಮ್ಯುಲೇಷನ್ ಟೈಮ್. ಇನ್ ದ simulation time only, simulation time the time of what the simulation time will give what the time integer time data types are used in the time data. Keyword is what the time always. Okay, next is what the arrays. Saka ಸಾಕು ಮೇಡಮ್? ನೋಟ್ಸಾ? ನೋಟ್ಸ್ ಡಿಕ್ಟೇಟ್ ಮಾಡೋದ? Let me explain all the things. Later I will dictate. Okay? Next one is what the arrays. Arrays ಅಂದ್ರೆ ಏನು ಹೇಳ್ರಿ? It's what the set of similar. Next class ಆಯ್ತು, ಸರಿ. Okay. ನೆಕ್ಸ್ಟ್ ಇನ್ನೂ ಎರಡೇ ಕಾನ್ಸೆಪ್ಟ್ ಅವ ಅಮ್ಮ, ಫಾಸ್ಟಾಗಿ ಮುಗಿಸ್ಬಿಡ್ತೀನಿ, ಆಮೇಲೆ ನನಗೆ ಟೈಮ್ ಆಗಲ್ಲ, ಆಮೇಲೆ ನೋಟ್ಸ್ ಕೊಡ್ತೀನಿ. ಒಂದು ನಿಮಿಷ ಫಾಸ್ಟಾಗಿ ಹೇಳ್ಬಿಡ್ತೀನಿ. ಇಟ್ಸ್ ಕಲೆಕ್ಷನ್ ಆಫ್ ವಾಟ್ ದ ಅರೇಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ಸ್ ಎ ಕಲೆಕ್ಷನ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್. ಆಮೇಲೆ ಬರ್ಕೋದ್ರಿ ನೋಟ್ಸ್ ಕರೆಕ್ಟಾಗಿ ಕೂತ್ಕೊಂಡು ಕೇಳ್ರಿ. ಅರೇಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ಸ್ ವಾಟ್ ದ ಕಲೆಕ್ಷನ್ ಆಫ್ ಸಿಮಿಲರ್ ಎಲಿಮೆಂಟ್ಸ್. ಬೇರೆ ಬೇರೆ ಎಲಿಮೆಂಟ್ಸ್ ಇದ್ರೆ ಅರೇಸ್ನಾಗ ಹಾಕಕ್ ಬರುತ್ತಾ? ಹಾಕಕ್ ಬರಲ್ಲ. ಯು ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ಇನ್ ದ Java, yes, no, advanced Java ಓದಿಲ್ಲ. Similar elements, same the data types are used in the what the in the Verilog also. The here's what the array name, which can be name initialized with what the array name, then the index here. ಎಷ್ಟು ಅರೇ ನೇಮ್ ಇರ್ಬೋದು, ಯಾವುದೋ ಒಂದು ಎಕ್ಸ್ ಇದೇನೋ ಇತ್ತಂತ ಇಟ್ಕೋ, ಯಾವುದೋ ಸಿಸ್ ಅರೇ ಇತ್ತಂತ ಇಟ್ಕೋ, ಅದರೊಳಗೆ ಒಂದು ಇಂಡೆಕ್ಸ್ ಕೊಡ್ಬೇಕು 2. ಓಕೆ, ಇಟ್ಸ್ ವಾಟ್ ದ ಸಿಸ್ ಇಸ್ ದಿ ಅರೇ ನೇಮ್ ದಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಇಂಡೆಕ್ಸ್ ಇಸ್ ವಾಟ್ ದ 2 numbers. How many numbers are 2 numbers of systems are there? 1, 2 systems are there. Like this, if I use the integer type, integer array count. Okay, count of what 0 to 3. Okay, this is what the this is also what the integer type. This is the array type. This will be start count is from the 0 to 3 only. And also even I can also have the register type of array. This is also having the values is the boolean type. That's to be what the 31:0. It's what the size of the same elements which is having the 32 numbers of arrays are elements are in this array also. Like this we'll have the different types of arrays are there. Like this V1 you can also checkpoint is what the value here the 100. Okay, 100 equals to what the 0. Checkpoints which is having the how many checkpoints are there, how many hundreds are there, which are all are what the 0, which are not having the any active. They are all inactive only. Checkpoints are always how many checkpoints are there? 100 checkpoints are there, which are all what are those? Inactive, not a active one. This is all about the arrays type. And also memories is there. Next point is what the memories. Memories are usually modeled with the help of what the and one dimensional. Okay, one dimensional. ಈಗ ರೆಜಿಸ್ಟರ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಹೇಳಮ್ಮ, ಸಿಂಗಲ್ ಪಾಯಿಂಟ್ ಸಿಂಗಲ್. ಈ ಒಂದು ರೆಜಿಸ್ಟರ್ ಒಳಗೆ ಎಷ್ಟು ಬಿಟ್ಸ್ ನಾವು ಇನ್ಫಾರ್ಮೇಶನ್ ಸ್ಟೋರ್ ಮಾಡ್ಬೋದು, only one bit, either it's for the 0 or 1. Register having the default value is what the x ಇರುತ್ತೆ, register value and default value is the x ಅದ. ಅದ್ರಾಗ ನಾವು that can store only what the 1 bit of information. If you want to have the more number of information, more bit of information, then I will go with what the memories. That will go with what the memories. Register ಏನ್ ಮಾಡ್ತದ, ಒಂದೇ ಬಿಟ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಸ್ಟೋರ್ ಮಾಡ್ಕೋತದ. ಬಟ್ ಮೆಮೊರಿ ಏನಿರ್ತದ, this what the one dimensional register bond. This what the one dimensional array of registers. This what the one dimensional array of registers. Okay, after completion of this memory, I'll detect the nodes. Okay, wait. Memory is nothing but the one dimensional. These are modified. These are modeled in the Verilog with the help of what the one dimensional array of what the registers. Register can store only one bit of information. If you want to have the multiple number of bits of information stored, let's go with what the memory. That is what the one dimensional form. Okay, usually the known elements, each of the element of the array is what the known element only. Those to be what the addressed with what the single address. ಈಗ ಒಂದಾದಂತ ಇಟ್ಕೋ, ಇದೇನದ ಒಂದು ಮೆಮೊರಿ ಅದ. In memory, the memory is divided into number of bits. Okay, number of what the address spaces here. This address space is having what the particular address. This address is having the another address. This is address 1. This is the address 2. Okay, this memory is completely, will not use the completely one. Will particularly this address memory, this address of this memory will use the storage purpose. Complete memory adana ostu adrag haklak agutte anna hakak agalla. Will not store, will not use that particular completely memory. The part of the memory element is used for the storage purpose, that is having the separate address name. ಇದಕ್ಕೊಂದು separate address name ಬೇರೆ ಇರುತ್ತೆ, ಇದಕ್ಕೊಂದು separate address name ಬೇರೆ ಇರುತ್ತೆ. Okay, for example, this is my memory. Okay, memory bit is what the memory bit is there. Each and every bits are there, 0 to 123, 0 to 131. This is what the memory. This one we call what the register. This one is the second register, like this, like the register 1, register. This is what the array of registers. This is what the array of registers which are having the one dimensional form only. ಒಂದು ವೇಳೆ ನಾನು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ. ಈಗ 7:0 register is what the 7:0 ಅದ, 7:0. This is what the registers of what the vector form only. Vector form which is having the part of selection form which is having the 7:0. ಈ ಮೆಮೊರಿ ಇದು ಈ 7:0 ಬರಿಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡಬೇಕು, ಇದು ಆ ತರ ಮೆಮೊರಿ ಹಾಕಬೇಕು. How many registers I need here? 8 registers I need here. 0 to 1. This is what the memory. Like this we can define our memory and also design our memory. We'll also have the usually the megabytes ಅಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ್ತಿರ್ತೀವಿ ಅಲ್ಲ, megabytes ನಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ್ತಿರ್ತೀವಿ. ಮೆಗಾ ಅಲ್ಲ, ಮೆಗಾಬೈಟ್ಸ್ MB ದಾಗೆ ಸ್ಟೋರ್ ಮಾಡ್ತಿರ್ತೀವಿ ಆಲ್ಮೋಸ್ಟ್ ಆಲ್. Next I left with what the parameters and the parameters and strings. Okay, strings and parameters are used what the some values assignment. ಈ ವೇರಿಯಬಲ್ ಗೆ parameters ಏನು ಡಿಫರೆನ್ಸ್ ಅದ? What is the difference between the variable and the parameter? ನೀವು ಓದಿರಲ್ಲ, ಜಾವಾದಾಗ ಓದಿರೋದಾ? You are studying the Java. There is a difference, slight difference between the variable and also parameter. What is that? Parameters na assign ಮಾಡ್ತಾರೆ, variables ಗೆ variables can be different in the parameters. For example, this one is called what the For example, variables can be named with what was the x, y, z, like this. Each variable can have its own parameter value. As for example, x equals to what the 25. Here what is the variable? X is what the variable. 25 is what the parameter. We are sending what type of value as the integer type. Okay, these are the width. Okay, we can also send the parameter width also. Parameters, keyword for the parameter is used for the parameter itself. Parameter keyword ಏನು ಯೂಸ್ ಮಾಡ್ತೀವಿ, parameter ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Parameter x equals to 25. This is what the parameter type of parameter. This is a variable x equals to 25. Even I can also define the parameter port ID 5. This is what the I am defining the variable. This is port ID is what the variable which is having the value as the what the 5. This is what the parameters defining. And also I am like this we'll have the different types of variables and the parameters value also. This is what the parameters one. And also next one is what the strings. Strings. Next one is what the strings. Strings are nothing but this is what the variable form. Each and every string has its own value. Okay, that's nothing but this can be varied from the positive or negative. If I use the only one string, this is it the string one? Is it string? No. Yes, this is what the character. It's what the group of characters are called as the strings. This is what the group of characters is called strings. This string can be either it is what the incrementing one or else it's a decrementing one. We can have either it's what the incrementing one, decrement one. We can define the string always with the string keyword, and also we define the string register which is what the register. It can store the values as the 8 like this. It's what type of string register is storing the values is in the form of the string which is having the length as the 8 bits only. The name ಇರುತ್ತೆ ಈಶ್ವರಾಜ್ 8 ಅಕ್ಷರದ ಅದು more than 8 letters ತಗೋತಿದ್ರೆ ಅದು increment 1 ಪ್ಲಸ್ ಕೊಡಬೇಕು. ಡಿಕ್ರಿಮೆಂಟ್ ಫಾರ್ಮ್ ನಾಗ ಯಾವ್ದಾದ್ರು ಕೌಂಟ್ಸ್ ನಾನ್ ಕೌಂಟ್ ನಂಬರ್ಸ್ ಏನಾದ್ರು ನಾನು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಸ್ಟ್ರಿಂಗ್ ರೀಡ್ ಮಾಡೋದಿರ್ತದ, ಯಾವುದೋ ಒಂದು ಬರ್ದಿರ್ತೀರಿ ಸೆಂಟೆನ್ಸ್ ಬರ್ತಿರ್ತಿ, ಆ ಸೆಂಟೆನ್ಸ್ ಹೆಂಗ್ ರೀಡ್ ಮಾಡಬೇಕು ವೆಲ್ ಗಿವಿಂಗ್ ವಾಟ್ ದ ಇನ್ಕ್ರಿಮೆಂಟಿಂಗ್ ಆರ್ ಡಿಕ್ರಿಮೆಂಟಿಂಗ್ ಒನ್. ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡ್ಬೇಕು, ಇನ್ಕ್ರಿಮೆಂಟ್ ಮಾಡ್ಬೇಕು, ರೀಡ್ ಮಾಡಾಗ ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ರೀಡ್ ಮಾಡೋದಿರ್ತದೆ ಒಂದ್ ಲೆಟರ್ ಆಗಿದೆ ಒಂದ್ ಲೆಟರ್ ಆಗಿದೆ ಫಾಸ್ಟ್ ಆಗಿ ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡಿದಿರ್ತ. ಕಂಪ್ಲೀಟ್ ಆಗಿ ತೊಗೊಂಡ್ರೆ ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡ್ಬೇಕು, ಇಲ್ಲ ಒಂದೊಂದು ಒನ್ ಬೈ ಒನ್ ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡಿ ಇಲ್ಲ ಇನ್ಕ್ರಿಮೆಂಟ್ ಮಾಡೋದು. Like this we'll have this is also another type of parameter data type which is used in the Verilog HDL. Okay, this is all about the Verilog HDL's data types. How many data types are there? 8 data types are there. 8 data. One is what the first one is what the value set, another one is the nets, third one is what the registers, fourth one is the vectors, fifth one is the integer, real, time, like this. Sixth one is what the arrays, seventh one is what the memory. Eighth one is what the parameter, ninth one is what the strings. There are 9 are there, 8 alla 9 data types are there. Like this we have to define. In the examination they will ask what are the data types, explain the any 5. On the 10 marks you define like this. We have to mention the 9 data types ಬರ್ದು any 5 ಅದರ 5 ತಗೊಂಡು explanation ಕೊಡಬೇಕು for the 10 marks. This is what the fixed question, 100% fixed. There is no chance for him to give the ask the other than these questions. Okay, take the heading as the variable vector form. Variable vector, first one is what there are 2 types of vectors. There are 2 types of vectors. One is the vector part select, another is the variable vector part select. First one ಬರ್ಕೊಂಡ್ರಲ್ಲ ವೆಕ್ಟರ್ ಪಾರ್ಟ್ ಸೆಲೆಕ್ಟ್ ಆಗಿದೆ ನೀವು ಎಲ್ಲಿ ತನಕ ಆಗಿದೆ ಇಂಟಿಜರ್. ಓಕೆ, ಇಂಟಿಜರ್ ಅದು ಬರ್ಕೊಂಡ್ರಿ. ಸೊ ದಟ್ಸ್ ಮಚ್ ಇಸ್ ಎನಫ್ Anyway, I'll be sending the soft copies there with me. Definitely today I'll sending that one. Don't worry. ಸಾಫ್ಟ್ ಕಾಪಿ ಇದೆ, ನನ್ನ ಹತ್ರ ಕಳಿಸ್ತೀನಿ ನಿಮ್ಗೆ. ಬುಕ್ ರೆಫರ್ ಮಾಡ್ರಿ, ಇಲ್ಲಿದೆ ಯಾವ್ದು ಹೇಳ್ಬೇಕು, ಯಾವ್ದು ಡಿಟೆಕ್ಟ್ ಮಾಡ್ಬೇಕು ನೋಟ್ಸ್. ಇಂಟೀಜರ್ಸ್. ಆ್ಯನ್ ಇಂಟೀಜರ್ ಈಸ್ ಎ ಜನರಲ್ ಪರ್ಪಸ್ ರೆಜಿಸ್ಟರ್. ಆ್ಯನ್ ಇಂಟೀಜರ್ ಈಸ್ ಎ ಜನರಲ್ ಪರ್ಪಸ್ ರೆಜಿಸ್ಟರ್. Register type, general purpose register data types. An integer is a general purpose register data type used for manipulating the quantities. Manipulating the quantities. Quantities manipulate ಮಾಡಬೇಕಾದ್ರೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Manipulating the quantities. Integers are declared. Next point. Integers are declared with the keyword. Integers are declared with the keyword integer. Integers. Next point. Integer data types are used for the. Next point. Integer data types are used for the counting the for counting next is what? And also next point is integers are next point is what? The default width for the integer is default width for an integer is host machine used size is the host machine word size. ಈಗ ಹೋಸ್ಟ್ ಮಷಿನ್ ಅಂದ್ರೆ ಯಾವ್ದು ಇರ್ತದೆ ಅಲ್ರಿ? ಕಂಪ್ಯೂಟರ್ ನಾಗ ಬಿಟ್ ಆಫ್ ದಟ್ ಎಷ್ಟು ಅಂತ ಕೇಳ್ತಿರ್ತಾರೆ. ಎಷ್ಟು ಬಿಟ್ 32 ಬಿಟ್ 64 ಬಿಟ್ ಈ ತರ ಕೇಳ್ತಿರ್ತಾರೆ. ನಮ್ಮ ಪ್ರೊಸೆಸರ್ ಯಾವ್ದು ಇರ್ತದೆ ಅದ್ರದ್ದು ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರ್ತದೆ ಇದು ಇಂಟಿಜರ್ ಬಿಟ್. ನೀವು 8 ಬಿಟ್ಸ್ ಆಫ್ 16 ಬಿಟ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ನೌ ಇಟ್ ಇಸ್ ಹೌ ಮೆನಿ ಬಿಟ್ಸ್ ಆಫ್ ಪ್ರೊಸೆಸರ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್? 32 ಬಿಟ್ ಆರ್ 64 ಬಿಟ್? 64 ಬಿಟ್ ಅವಾಗ ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ, ವರ್ಡ್ ಲೆಂತ್ನು 64 bit ಆಗುತ್ತೆ. Similarly, the integer width of that particular system is what the host size is what the 64 bit only. This is what the host machine word size, comma, which is implementation specific. In bracket naga ಬರ್ಕೋರಿ, at least 32 bits. Registers integers are assigned values. Next, integers are assigned values inside a initial statement. ಈಗ ಹಂಗೆ ಇನಿಷಿಯಲ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರೆದ್ಮೇಲೆ ನಾವು ಇಂಟಿಜರ್ ವ್ಯಾಲ್ಯೂ ಡಿಫೈನ್ ಮಾಡ್ಕೋ. Integers are assigned values inside a initial statement. Integer, for example integer count, small letter ಬರ್ಬೇಕಾ, count semicolon initial count equals to -1. Okay, this is what the declaring of the integer type. What type of this integer? Count type. This is what the declaring. Okay, this one declaring of a variable, declaring a variable ಈ ವೇರಿಯಬಲ್ ಇದು ವೇರಿಯಬಲ್ ಅಲ್ಲ, ಇದು ವೇರಿಯಬಲ್ ಅಂದ್ರೆ ಚೇಂಜ್ ಆಗ್ತದೆ ಅಂತ. ವೇರಿಯಬಲ್ ಕೌಂಟ್ ಆಸ್ ಇಂಟಿಜರ್. ಈ ಕೌಂಟ್ ಏನಿರ್ತದೆ ಚೇಂಜ್ ಆಗುತ್ತೆ ಆಗಲ್ಲ, ಐದರ್ ಇಟ್ಸ್ ವಾಟ್ ಇಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ ಡಿಕ್ರೀಸಿಂಗ್, ಇನ್ಕ್ರೀಸ್ ಆಗ್ಬೋದು ಡಿಕ್ರೀಸ್. ದಟ್ಸ್ ವಾಟ್ ದ ಡಿಕ್ಲೇರಿಂಗ್ ಆಫ್ ಎ ವೇರಿಯಬಲ್ ಕೌಂಟ್ ವೇರಿಯಬಲ್ ಆಗ್ತದೆ. ಅದು ನಾವು ಏನಂತ ಡಿಕ್ಲೇರ್ ಮಾಡ್ತೀವಿ, ಇಂಟಿಜರ್ ಟೈಪ್ ಆಫ್ ಡಿಕ್ಲೇರ್ ಮಾಡ್ತಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ಇನಿಷಿಯಲ್, ಓಕೆ. ನೆಕ್ಸ್ಟ್ ಕೌಂಟ್ ಇಸ್ ವಾಟ್ ದ ವ್ಯಾಲ್ಯೂ ಇಸ್ ವಾಟ್ ದ -1. ಇಟ್ಸ್ ವಾಟ್ ದ we can define the store is -1 in count. In the integer variable, count ಒಳಗೆ ನಾವು ಸೇವ್ ಮಾಡ್ತಿರ್ತೀವಿ, ಸ್ಟೋರ್ ಮಾಡ್ತೀವಿ. ಯಾವುದು? -1. ನೆಕ್ಸ್ಟ್ ಟೇಕ್ ದ ಹೆಡಿಂಗ್ ಆಸ್ ದಿ ರಿಯಲ್. ಇಂಟಿಜರ್ ಆಯ್ತಾ, ನೆಕ್ಸ್ಟ್ ರಿಯಲ್ ತಗೋರಿ. ರಿಯಲ್ ನಂಬರ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್. ರಿಯಲ್ ನಂಬರ್ಸ್ ಆರ್ ದಿ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್. ಈಗ ಯೂಸ್ ಒಂದ್ ವೇಳೆ ಪೈ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಪೈ ವ್ಯಾಲ್ಯೂಸ್ ಪೈ ಅಂತ ಬರ್ದಿರ್ತಿರ್ತಾರೆ. ಪೈ ವ್ಯಾಲ್ಯೂಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಸ್ ವಾಟ್ ದ ವ್ಯಾಲ್ಯೂ 3.14. ಅಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಆಲ್ಸೋ ಡಿಫೈನ್ಡ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಫಾರ್ ದ ರಿಯಲ್ ನಂಬರ್ಸ್ ಓನ್ಲಿ. ಓಕೆ, ರಿಯಲ್ ನಂಬರ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಅಂಡ್ ರಿಯಲ್ ರೆಜಿಸ್ಟರ್ಸ್. Real number constants and real registers. Data types are declared with the real number constants and real registers are data types are defined declared with the keyword real. ರಿಯಲ್ ಅಂತ ಬರ ತಕ್ಷಣ ಏನ್ ಬರ್ತದೆ, ಅದು ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಇರ್ಬೋದು, ಐದರ್ ಇಟ್ಸ್ ವಾಟ್ ದ ನಂಬರ್ಸ್ ಆಗಿರ್ಬೋದು, ರಿಜಿಸ್ಟರ್ ವ್ಯಾಲ್ಯೂ. ಓಕೆ, ರಿಯಲ್ ನಂಬರ್ಸ್ ನೆಕ್ಸ್ಟ್ ಒನ್ ರಿಯಲ್ ನಂಬರ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಸ್ಪೆಸಿಫೈಡ್ in the decimal as 3.14 for pi value. 3.14 for pi value as our next point our scientific notation as 3E6 as scientific notation 3E6. ಇದು ಹೆಂಗ್ ಬರೀಬಹುದು? for 3 into 10⁶. for scientific notation 3E6 which is 3 into 10⁶. Next point, real numbers cannot have the range declaration. We don't have the real numbers range declaration ಮಾಡ್ತೇವೆ 3:0 ಹಂಗೇನಾದ್ರು ಮಾಡ್ತೇವೆ ಇಲ್ಲ. ರಿಯಲ್ ನಂಬರ್ಸ್ ಅಲ್ಲಿ ರೇಂಜ್ ಡಿಕ್ಲರೇಷನ್ ಇರಲ್ಲ. ಈಗ 3:0 1:4 like this. We don't have the range declaration. And default value of real number is 0. real number ಬರಿಬೇಡ್ರಿ. real is what the 0 ಅಂದ್ರೆ 0 ನ ಬರೀರಿ, ZERO ಬರಿಬೇಡ್ರಿ, 0 ನ ಬರೀರಿ, 0. Next point, when a real value is assigned to an integer, when a real number is assigned to an integer, comma, the real number is rounded off rounded off, O double F, rounded off to nearest integer, nearest integer. Next point. Okay, for example, we can define the data types as the real delta. For example, real delta, comma, it should be defined in the initial statement only, below the initial statement, begin and the end also. Okay, in the delta, within this block, begin block, we have to define what the delta values. Delta values, what the delta values? 4E10. Okay, and also we want to define the delta value equals to 2:14, something you write. Okay, this is what the declaring, what the you can write of your own explanation. This is to be nearest value as the, this can be defined as the 4 into 10^10. This is what the, this is rounded to what the 3:14. Sorry, 13 adala. 13 is then what 3:13. It's to be rounded to what the 2 only. It's near to 2, not a 3. Okay, next is what the time. Next is what the time. Time is very long. This time is what the data type which is used for the simulation purpose. In the simulation done, Verilog simulation is done with respect to simulation time. Barkore, Verilog simulation is done. Verilog simulation done with respect to simulation time. The time variable is declared with the keyword time. Next point, time variable is declared with the keyword time. A time variable is declared with the keyword time. Small letter time. The width of the time register is data types is the width for time register data types is implementation specific, but at least ನೀವು ಎಷ್ಟಾದರೂ ಕೊಡಬಹುದು ಟೈಮ್ ಸ್ಪೆಸಿಫಿಕ್, ನೀವು ಎಷ್ಟಾದರೂ ಕೊಡಬಹುದು ಇಂಪ್ಲಿಮೆಂಟೇಷನ್ ಸ್ಪೆಸಿಫಿಕ್, ಎಷ್ಟಾದರೂ ಕೊಡಬಹುದು, ಬಟ್ ಅಟ್ ಲೀಸ್ಟ್ ಇಟ್ ಶುಡ್ ಬಿ ವಾಟ್ ಅಟ್ ಲೀಸ್ಟ್ ಬಟ್ ಅಂತ ಬರೀರಿ, ಬಟ್ ಅಟ್ ಲೀಸ್ಟ್ 64 ಬಿಟ್ ಅಲ್ಲಿ ಇರಬೇಕು, 64 ಬಿಟ್, ಬಟ್ ಅಟ್ ಲೀಸ್ಟ್ 64 ಬಿಟ್, ಬಟ್ ಅಟ್ ಲೀಸ್ಟ್ 64 ಬಿಟ್, 64 ಬಿಟ್ಸ್ ಅಂತ ಮಾಡ್ರಿ, 64 ಬಿಟ್ಸ್. ಅಮ್ಮ the width of for the data time register data type is implementation specific, but it should be have the at least 64 bits. The time, okay, if I use the dollar specific, okay, if I use the dollar with the time, this indicates what this is the current time, current simulation. Barkori, if dollar with the time, if dollar with the time, adu hange bariri, with dollar with time, system function is invoked to get the current simulation time. ಈಗ ನಾನು ಕರೆಂಟ್ ಸಿಮ್ಯುಲೇಷನ್ ಟೈಮ್, ನಾನು ಇಫ್ ಐ ವಾಂಟ್ ಟು ಗೆಟ್ ದ ಕರೆಂಟ್ ಸಿಮ್ಯುಲೇಷನ್ ಟೈಮ್, ಈಗ ಡಿಫಾಲ್ಟ್ ವ್ಯಾಲ್ಯೂ ಇರ್ತದ ಎಷ್ಟು, 64 ಬಿಟ್ ಆಫ್ 64 ಬಿಟ್ಸ್ ಆಫ್ ವಾಟ್ ದ ಐ ಆಮ್ ಯೂಸಿಂಗ್ ದ ಕೀ what the word length, this type of processor I am using. This processor is using having the time specific, it has the some simulation time. ಇದು ಈ ಸಿಸ್ಟಮ್ ದ ಸ್ಪೆಸಿಫಿಕ್ ಟೈಮ್ ಎಷ್ಟು ಅಂತ ಗೊತ್ತಾಗಬೇಕಾಗಿತ್ತು. ಅಂದ್ರೆ ಇಫ್ ಐ ಯೂಸ್ ದ ಇನ್ ದ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ದ dollar with the time, it will get fetch the what the system specification time. ಅದ್ರದ್ದು ಎಷ್ಟು ಕೊಟ್ಟ ಸಿಮ್ಯುಲೇಷನ್ ಟೈಮ್ ಡಿಫಾಲ್ಟ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಅಂಬೋದು ಗೊತ್ತಾಗುತ್ತದೆ. ನೆಕ್ಸ್ಟ್ okay, time specification is also be done with what the same as the in the initial block only. Okay, ಇದು ಮಾಡಲ್ ಆಯ್ತಲ್ಲಪ್ಪ, ಸಾಕು ಮಾಡಮ್ಮ. ಟೈಮ್ ಆಯ್ತಾ, ಒಂದಾಗಿದ್ರೆ ಸಾಕು ಮಾಡಮ್ಮ. ಇನಫ್, ಡೆಫಿನೆಟ್ಲಿ ವಿಲ್ ಕಂಪ್ಲೀಟ್ ದಿಸ್ ಒನ್. ಟೈಮ್ ಸಿಮ್ ಅಂದ್ರೆ ಸಿಮ್ಯುಲೇಷನ್ ಟೈಮ್ ಅಂತ ಅರ್ಥ. ಸಿಮ್ ಅಂಡರ್ಸ್ಕೋರ್ ಟೈಮ್. Okay, you have to use the initial block. Initial. Okay, here you have to mention the sim time. Sim time equals to dollar time. Okay, simulation. Next part. Simulation time is always measured in terms of simulation seconds. In terms of simulation seconds, the unit denoted by S. The unit denoted by S. Next is what? Arrays. ಬರ್ಕೋತೀರಿ ನೀವು ಬುಕ್ ನೋಡಿ, ನಾನು ನೋಟ್ಸ್ ಕಳಿಸ್ತೀನಿ. ಇದು ಬರ್ಕೋತೀರಿ ಸಾಕು ಮಾಡಿ. ಓಕೆ, ಐ ಹ್ಯಾವ್ ಗಿವನ್ ದ half of the model. Okay, second half of the model. Many questions ಬರ್ಸಿದ್ನಲ್ಲ, ಇದೇ ಸೇಮ್. Okay, what are the data types in the Verilog HDL? Explain the any 5 ಅಂದಾಗ any 5 explain ಮಾಡೋಕೆ. What are the lexical conventions in the Verilog HDL? Explain the any 5. These are the 2 fixed question. ಯಾವ ಕೇಳಿದ್ರೆ ಇವಾಗ ಕೇಳ್ತೀನಿ 100%.